revision as we are revising quadratic number patterns, those that you dealt with in 2025 last year. Before we start on number sequences, we just have to make sure you remember these. This is an interesting question. I hope you will find it interesting. Before you watch the whole video, try to do the question yourself. Then when you have tried it, you can come back and watch the video. The other thing that I want you to know is to determine the level of that question. Is it a level 1 question, a level 2 question, a level 3, or a level 4? All right. The question is saying a quadratic number pattern has the following properties. We are not given the terms of this pattern, but we are given certain properties. The first one, the second difference is 10. It's a quadratic, right? Okay, changing color here, black. It's a quadratic, right? Now, if it is a quadratic, that should tell us that the 10 there is constant because it's the second difference. And then the first two terms are equal. We do not know these terms, so we can tentatively say it's x and x. Those are the first two terms. And then the first three terms add up to 28. The third term, we do not know it, but we are told that these three, when you add them, they give you 28. Those are the only properties that we are given. We can make use of these properties. This is a quadratic number pattern, so we can just do what we are used to when we are dealing with quadratic number patterns. We want the first line of differences, x minus x. This is a 0 here, and then we are told that the second line of difference, which is constant, is 10. So we have a 10 here, so we can determine this one. 0 plus 10, so it means this is a 10. X plus 10, so it means here we have x plus 10. So we have the first term, the second term, and the third term. So we have our quadratic pattern now, though it's made up of unknowns. The first question is saying, show that Tn is equal to this. Tn is equal to this. For you to show that Tn is equal to that, you need to find the value of, we need to show that A is equal to 5, B is equal to negative 15, C is equal to 16. Remember, Tn is equal to an squared plus bn plus c. So show that A is equal to 5, B is negative 15, C is equal to 16. For you to be able to do that, you first have to determine the value of x here. So how do you determine the value of x? We are making use of this property here. The first three terms add up to 28. So we are simply saying x plus x plus x plus 10 is equal to 28. X plus x plus x plus 10. These are the three terms. This is the third term. They are equal to, they add up to 28. 1, 2, 3. So it's 3x plus 10 is equal to 28. 3x is equal to 10 goes to the other side, so it's 28 minus 10 is 18. So your x is equal to, divide both sides by 3. Your x is 6. So we can come back here and rewrite our number pattern. The number pattern is like this. We have a 6. We have a 6 because the first two terms are equal, and the third term is x plus 10. So it's 6 plus 10. That gives us 16. And then our difference is now, our difference is 6 minus 6 is a 0. 16 minus 6 is a 10, and we know that the difference here is 10. So we can now determine the value of A, the value of B, the value of C. Our A here, I want a red, so it's 2A here is equal to this one. So your A is equal to, divide both sides by 2, your A is equal to 5. There is our 5. So we want the B here. 3A plus B is equal to the first term in the first line of differences. So it's equal to a 0 here. We have the value of a, it's a 5. So it's 3 by 5 plus b is equal to 0. This is a 15. When it goes to the other side, it becomes negative. So this is negative 15. It's 0 minus 15. There is our b there. And then our c is, how do we get the value of c? The value of c, we get it from the first term there. We know that a plus b plus c is equal to the first term, that is 6. Your a is a 5, we calculated it. Your b is a negative 15 plus the c that we do not know is equal to 6. This one is a 10. This is a negative 10. When the negative 10 goes to the other side, it becomes positive 10 plus this 6. Therefore, your C is equal to 16. And that's what we are looking for. So we are saying our A is equal to 5. Our B is equal to negative that. And our C is equal to that. And that is what we wanted to show there. So we've shown that Tn is equal to that, because we have seen that A is equal to 5, B negative 15, C is equal to 16. And then the next question. Is 216 a term in this number pattern? Is 216 a term in this number pattern? Okay, there is a mistake there. It was not 216, it's supposed to be 116. It's supposed to be 116. Am I right? Maybe just 5. Okay, we can work with it with the 216. So we are saying Tn is equal to this, and 216, is it a term in the pattern? So we are saying Tn is equal to 216. So we need to determine the value of n here. If n is a whole number, a positive whole number, then that confirms that this is a term in this number pattern. So to do that, to determine the position of 216 in this number pattern, we equate that term, that 216, to the general term. So we have 5n squared minus 15n plus 16 is equal to 216. All right. Take your 216 to the right, we have 5n squared minus 15n, so it's minus 200, and that is equal to 0. Because we are now saying 16 minus 216, we are left with minus 200. All right, how do we solve this equation? All of them are multiples of 5, so we can divide through by 5. Divide by 5 here, we have n squared. Divide by 5 here, we have 3n. And then minus, divide by 5 here, we have 40 minus 40, and that is equal to 0. Okay, that's more manageable now. We don't even need to use the quadratic formula. We can just factorize here. And we have negative 8 and positive 5, and that is equal to 0. Negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. Therefore, we are saying from this bracket, your n is equal to 8, or from this bracket, your n is equal to negative 5. But we know that n cannot be equal, n cannot be negative because it's a position. The position cannot be negative. So we are saying this is not. Therefore, T8 then is equal to 216. This concludes that 216 is a term in this number pattern, and the term is at position number 8. So this is the 8th term in that number pattern. Okay, that's all for this question. Let's look at the